This is another demonstration that's going to allow us to transition from this unit on oscillations into the next unit on waves and sound. Specifically, one of the things that we'll take a look at when we get to sound are musical instruments. As we'll describe at the time, all musical instruments resonate. Okay, now I have right here a very primitive musical instrument, and that's this wine glass. This wine glass is capable of playing only one note. For example, say when I strike it, like so. Now, when I strike it in that manner, based upon the shape of the wine glass then oscillates at its natural frequency. When it does, it brushes up against the air molecules that are immediately next to it. Air is a good transmitter of traveling oscillations, what are referred to as waves. In this case, specifically sound waves. The sound waves that you hear, the frequency of the sound waves is exactly the same as the natural frequency of the wine glass. Like so. Okay, now I've got this other equipment here set up on my desk. This right here, first of all, is a microphone that is picking up, for example, right now, the frequencies associated with my voice, and then transmitting those sound waves frequencies into an electronic signal, the frequency output that you can see here on the screen of this device. This device is referred to as an oscilloscope, an oscillator scope. And then what I have over here in the background is what is called a function generator. The function generator is capable of producing pure tones. The output of those tones comes out of this speaker right here. I'm going to position the wine glass in between the speaker, where sound waves are going to be emitted from, and the microphone, which then picks up those sound waves and converts it into an electronic signal that we can see. Now, when I turn on the function generator in just a moment, sound waves will be coming out of the speaker, and those sound waves will be striking the wine glass. If the frequency of the sound waves coming out of the speaker matches up with the frequency of the wine glass, then the wine glass will resonate. That is, it will oscillate with a large amplitude oscillation. If the sound is loud enough, and it does have to be really loud, by the way, I lack the equipment here to do that. If the sound wave is loud enough, it could literally cause the wine glass to shatter. There is a nice scene in one of the films that I'll have you watch on resonance that depicts this very nicely. But for now, I can demonstrate it here. Okay, so what I'm going to do is take the wine glass away from the speaker and now turn on my function generator, like so. And in just a moment, sound waves of a single frequency will be emitted here from the speaker. Those sound waves will then strike the wine glass, causing it to oscillate. Okay, now listen to the tone coming out of the speaker. Compare it to what you hear when I strike the wine glass. Pretty similar to each other. So now what I'm going to do is place the wine glass right here, and now I'm going to adjust the frequency. The output, of course, is here on the oscilloscope screen as well. I'm going to raise the frequency such that the frequency of the sound waves coming from the speaker matches the natural frequency of the wine glass. I'll know when I've got the right frequency when all of a sudden the sound gets a little bit louder. Right about there. Like so. Compare the sounds when I do this. Like so. The reason why you're hearing the sound as a little bit louder when the wine glass is here is because you're actually hearing two sounds. You're hearing a sound coming from the speaker, but you're also hearing a sound from the wine glass. Instead of me striking the wine glass, in this case, it's sound waves that are striking the wine glass coming from the speaker. The wine glass is resonating. As we'll see when we eventually get to musical instruments in our next unit, all musical instruments resonate. The first thing that you do when you play a musical instrument is you somehow set it into vibration. We'll get to that in much greater detail in the next unit on waves and sound.